This week I want to talk about integrating over regions that are not rectangles, something a little funkier. Of course we're not going to go over hard because that would just be too funky, but you get the idea. So let's try an example. So this one's all set up for us. We're going to integrate with respect to y first, and then with respect to x. We're going to look at just the inside first and ignore the outside, and then we'll deal with the x. So the first thing I'm going to do is integrate with respect to y. So I have the integral from 0 to 2. When I integrate with respect to the y, I'll get x squared y squared over 2, and this is going to be taken from 0 to the square root of x, and then I still have my dx. I don't want to forget to integrate. So next I will plug in the x, square root of x for y, and then 0 for y. X squared times square root of x squared is x. I plug a 0 in, I get 0, so I now have to integrate x cubed over 2. Integrating x cubed over 2 with respect to x, I get x to the 4th over 8, taken from 0 to 2. If I plug in the 2 to the 4th is 16, so I get 2 minus 0, so my answer is 2. In general, we can break the two types of regions up into two different types. That was repetitive. We can break it up into two different types. We could have this situation where we've got a function on top and a function on bottom, and we've got a clear starting and end point. So I'm going to want to cut this region up vertically, which means my inside integral is going to be with respect to y, and my outside integral is going to be with respect to x. So first y is going from the bottom function to the top function, and then x is going to run through the a to the b. The other possibility is that if it's on the side, something like this. Same idea, except now I want to chop it up horizontally, which means my inner integral is going to be from g1 to g2, so x will go from g1 to g2, where y will go from c to d. So let's try another example of this. So let's say we want to do this integral. I see y over x to the 5th plus 1. I really don't want to integrate with respect to x first because it's x to the 5th on the bottom. There's nothing on top. There's no natural log. There's no fancy function. This is just gross. I want to integrate with respect to y first, and then do the x on the outside, and hopefully something magical happens so I'll be able to do the x. This is the region I'm interested in. So as I said, I want to chop it up. I want to integrate with respect to the y first, so I'm going to chop this way. And my x is going to go from 0 to 1. So I have 0 to 1 will be my dx. Y is going to go from 0 to the top function, which is x squared. I have y over x to the 5th plus 1 dy. So my inner function, the thing I want to deal with first, is that chunk. Now, I just have a y. Integrating a y is easy. Y squared over 2. So I have the integral from 0 to 1. I still have x to the 5th plus 1 on bottom. I will have y squared over 2. And rather than putting the 2 here, I'm going to go ahead and put it outside here to get it out of my hair. And this has to go from 0 to x squared. And when I plug my x squared in, I square it again, so I'm going to get x to the 4th on top over x to the 5th plus 1. I put a 0 in, I get a 0 minus 0. Let's just leave that off. Okay, now I'm much happier. I see a nice x to the 4th on top. The derivative of the bottom is 4x to the 4th. I don't have that 4. I don't have that 5, but I can cheat and say, here's my 5. And then I'll put a 1/5 outside, so they will cancel. So I've got my magic 5 to help me do substitution. So this gives me 1/10 times, well, the integral of this, the derivative of the bottom is sitting on top, so I've got the natural log of x to the 5th plus 1. And I'm going to take this from 0 to 1. If I plug a 1 in, I get the natural log of 2. If I stick a 0 again n, I get the natural log of 1. Natural log of 1 is 0, so my final answer is a natural log of 2 over 10.
And that's a good place to stop.